Hello, everyone. Welcome to the DI 101 webinar series. I am Jared Evans. I lead the marketing function for Distribution International. If you are new to this webinar series, I will tell you that it is an incredible resource offered to Distribution International customers, partners, and associates. By partnering with our manufacturers and our industry experts, these webinars deliver informative presentations about industry trends, new technology, new products, and product applications. We're extremely excited today to partner with Thermal Ceramics for today's webinar. The webinar will discuss the use of fire-rated blankets on ductwork for two applications: grease-laden vapor extraction ducts and the use of fire-rated blankets for zero clearance to combustibles and shaft alternatives. A review of IMC and IBC language will be referenced. Air ventilation ducts and the use of fire-rated blankets when used as a shaft alternative. A review of IMC and IBC language will be reinforced. The second part of the webinar will also discuss the evolution and use of low biopersistent fiber blankets versus refractory ceramic fibers. Let me introduce our presenter. David Keys is the Business Development Manager for Thermal Ceramics, and he has a Bachelor of Science in Ceramic Science and Engineering from Penn State University. In 1991, he joined Thermal Ceramics as a sales representative, providing sales and marketing support for all product lines. In 2002 through 2020, he was Regional Fire Protection Sales Manager. And then in 2020, he became the Business Development Manager for Building and Construction. He has participated in code cycle meetings for NFPA 96, IMC, and IBC. He's given continuing educational courses to distributors, contractors, engineers, and inspectors in numerous states on the design, installation, and use of fire-related blankets. Obviously, he is super qualified, and we're glad to have him. We're proud to have Thermal Ceramics present today, and we thank them for their time. Also with us on the panel is Christopher Kimball. He's an account manager for Distribution International with, for Thermal Ceramics with handling the Distribution International account. So Chris, thank you for joining us as well. We will answer questions at the end of the webinar. To submit questions, please use the questions tab on the GoToWebinar control panel. You can submit your questions at any point during the webinar, and we will answer the questions at the end. Without further delay, I will turn this over to David Keys with Thermal Ceramics.
Hello, everybody. I know you can't hear me, or I can't hear you, but I did not put my phone number or contact information down on this home screen. So my email is david.keys@morganplc.com, and my contact is 610-393-2236 if you need to get back on something. So I've been asked to present, obviously, you've heard from Gerald, on three different subjects. One is a low biopersistent fibers. They trade in the market into different things, but when we first brought these products came to market, they were in the early 90s as a replacement or a alternate to the use of refractory ceramic fibers, which back then were getting a lot of bad press in the marketplace. And the product has evolved quite a bit since its first generation, like most things. But what Thermal Ceramics actually makes, this is our full product portfolio. We're involved in all sorts of high temperature insulation. We've got blankets, fibers, papers, boards. We're involved in fired refractory shapes, insulating fire bricks, monolithic castables, dense fired shapes, microporous and structural insulations. And we're really just gonna stick with the fiber end of it for the presentation at this point. So we've got what we refer to as a low biopersistence fiber. At one point in time, we were calling it a safe fiber or a soluble fiber, and all those little nomenclatures have gone away, and it's a low biopersistence fiber. And all manufacturers of ceramic fiber, at least here in the States, have alternates to the ceramic fiber which were low biopersistence. What that actually means is that if it does get inhaled into the lungs, there's a natural mechanism for its dissolution and breakdown. And what we've got, it's measured by the half-life of the actual product. And ceramic, the RCF, refractory ceramic fiber, being on the very right-hand side of the chart here as reference point of a 300, and that's reference to the asbestos of over 2,000. So it takes 300 days for the fiber, for half the fibers to dissolve. The LPS is low biopersistence fiber. AES is alkali earth silicate. That's the generic names for the actual low biopersistence fibers. They've got a half-life of 5 days. A higher temperature range has a half-life of 10 days. So they're much, if they get inhaled, then it's hard to get them not to be inhaled. They dissolve much quicker than ceramic fiber and significantly quicker than the asbestos. So if you're less than 40 days and in half-life, the government has, an EU has an exoneration level. So anything below 40 in a half-life means that you do not have to be labeled as a hazardous and different grades of hazardous fiber product. Ceramic fiber in different countries has different fiber exposure levels. In the US, we're at 0.2. Most countries are 0.2. Some countries are lower, 1 or 2 are actually higher. There are companies within the US who have selectively decided to go to a lower fiber level than 0.2 on the ceramic fiber. So we've got ceramic fiber, which is the 0.2 fiber levels, the low biopersistence fibers, which we're going to be talking about here, or the newer chemistries. There are no exposure levels, permissible exposure levels established on those products just because of the exoneration slide, half-life solubility that I had mentioned in the earlier slides. We've got a polycrystalline wool, which is a more of a higher temperature product that is the same as ceramic fiber. Crystalline silica is 0.025. That's pretty much a known carcinogen. They're just in there as reference points. There are different alkaline earth silica products out there. They vary in temperature range. They vary in their thermal conductivity or insulation abilities. Depending upon the manufacturer you're looking at, one of the manufacturers, alkaline earth silicate A, that's one of the manufacturers. B is a different manufacturer. The point of this slide is that there are companies out there making these products. The thermal conductivities are going to be different for the different products from the different manufacturers. This basically shows the relative comparison of the top line being refractory ceramic fiber. There's a high temperature soluble, low biopersistence fiber. I had to catch myself there, and a lower temperature version. And the ceramic fiber, high purity ceramic fiber, has a little bit better temperature use range than the high temperature alkaline earth or the low temperature alkaline earth. So there are trade-offs with the different products. The high purity ceramic fiber will take higher temperatures, continuous use temperatures, than the body soluble products. So if you need to go in the 2100 degree range, you're probably not looking at a low biopersistent fiber sort of product. Thermal conductivities in general are much better for the low biopersistence than they are for the ceramic fiber. The blue line being the low bile persistence. The orange line or red line, depending upon your end, is the ceramic fiber. So they do have a lower thermal conductivity. If you don't need the high temperature aspect of the ceramic fiber, low bile persistence will provide better insulation. This is once again providing the side-by-side comparison of the ceramic fiber versus the low bile persistence fiber. In general, thermal conductivity is much lower. Seems like I've just gone through this slide. The tensile strength of the fibers. The ceramic fiber will have a higher tensile strength than the low bile persistence fiber. Whether it's a low shot plus fiber, a high temperature fiber, or there's a magnesium silicate fiber out there, which is also classified as low bile persistence. But if you have a tensile issue where you're tugging and pulling on the fiber, and it's high temperature range, you need the high refractoriness of it, the RCF's the way to go. If it's a tensile issue, you may be able to use the alkaline earth silicate low bile persistence if you don't exceed the tensile strength of the actual product. So what the manufacturers do is they'll take in this low bile persistence product and treating it just like it's the ceramic fiber, and it comes in the same formats and the same forms as the ceramic fiber. We'll take it, we'll make it into blankets, we'll make it into bulks. We encapsulate it for fire protection applications. It's made into modules, both folded and stacked modules. And so next part of the presentation is on grease ducts. Following the grease ducts, there's an air duct presentation. So in the early 90s, we actually, when we were developing the low bile persistence fiber, incorporated that into a product which was used for grease duct applications. And it's used on a grease duct applications and an air duct application. I'm getting into it a little bit, the air duct a little bit later, some of those details. But it's used to meet certain aspects of the mechanical and the building code. And there's 3 manufacturers out there now making the grease duct wrap products and air duct wrap products. You've got ourselves, Morgan Advanced Materials Thermal Ceramics. Unifrax is making a product, and 3M is also selling a product. So what these grease duct products actually do is they help contain a fire in the grease duct when the grease duct is not properly cleaned and the grease gets built up. There are sections in the code which have access doors for these grease ducts, and they're supposed to go, the restaurant owners are supposed to go in and clean the grease ducts at a period of time. Some do, some don't. There's no designated level of time because a Chinese restaurant could generate much more grease than a church which is only using their hood system 3-4 times a year. So there's no designated, thou shalt do this every month, thou shalt do this once a year. It's up to the owners. This duct has obviously not been cleaned, but this is what a duct can look like if it's been neglected. This is all grease built up inside the duct. So this is a quick little video that was captured on the news. You can just get an idea of what the fires actually look like, and this is a very short run at the bowling alley pizza grease duct hood. So that's what it looks like. These things get sparked off, the grease gets built up in the ductwork. Somehow there's usually a flash of flames, just like when you're cooking a burger on your grill. It gets too high, gets into the ductwork, ignites the grease, and then it burns. And it burns pretty hot. Could burn a while, could burn a brief duration, but to keep that fire from taking down the building code and the mechanical code and NFPA 96, NFP 96 being recognized in a few jurisdictions, the international code being recognized in the majority of the US. These codes have implemented language which basically says if you have a grease duct in a building, type 1 grease hood is one that's used in a restaurant. It's not one that would be above your kitchen hood in your house. This is a commercial setup. So if you've got ductwork in a building that's exhausting grease vapors, you need to keep that duct 18 inches away from combustibles. And the rationale for that is if there is a fire within that duct, that it's going to get red hot and it's got to be 18 inches away from combustible materials, far enough away so that the wood joist or whatever's there is not going to heat up and catch fire. Well, the problem for the designers and the owners and everybody else is that 18 inches on every side of the duct, and it takes up space, and space is expensive, and space is rentable, and things get in the way, and it's a problem to maintain that 18 inches clearance from the duct. If you look at these typical job sites, the duct at the bottom right-hand side, on the left is a grease duct because it's all rusty and it's black iron. On the right is an air duct. There is just not 18 inches of space between the two. Looking up at the top, same situation. These are typical job sites, and you just cannot maintain 18 inches away from these ducts. So the code also says that you need to maintain 18 inches, but it gives you some exceptions for grease ducts. And the exception is if you take a grease duct and you test it to this ASTM test 2336, you can get a zero clearance system. It doesn't say what you need to do to get there, whether it's a 1-layer or 2-layer system or something funky, double wall or anything. But if you have a field assembled grease duct and you test it with a product to pass this ASTM test, you now have a product which can be wrapped around the duct for zero clearance. And that's what the 3 manufacturers have done with this. This is a little picture of what the test assembly for 2336 actually looks like. There's a burner here with a 3-inch gas line. They have to heat this thing for 4 hours at 500 degrees and then take it up to 2000 degrees, which simulates a grease fire, and keep the outside of it, of the wrapped duct you see in the background, below the temperature at which it could potentially cause combustibles to burn. And that's defined as 325 degrees on average. That's what we have to keep the outside of this duct at when there's a 2000 degree internal temperature. Once again, the test does not say 1-layer or 2-layer. It just says you have to pass the test. After we do that, we actually have to take the duct, a different duct, and drop it into a furnace and heat it for 2 hours to a different fire curve. The building, it's ASTM E119, which is what is used for standard construction materials, and make sure that the duct does not collapse and the opening at the penetration stays intact. It's basically about keeping the fire either in the duct when it's in the duct or in the room as the duct travels through that room, so that you're keeping the fire separated from its point of origin, away from other things. So we passed the ASTM test, or the other guys passed the ASTM test, and what you get is a UL listing, which says for us, 2 layers around the grease duct. It addresses the joints, how they come together. It addresses the banding. It addresses the gauge of the duct, the access doors, the penetrations. This is what you'll get. We've got a UL listing. Their Intertech gives listings on their products. 3M and Unifrax have their listings with Intertech. They are both recognized by the building community as NRLs, nationally recognized labs, certified to run tests on grease duct assemblies. So this is back where we are. This is a slightly different section of the mechanical code, but it addresses your 18 inches from the duct to combustible materials. It also allows 6 inches to a limited combustible material, which is considered sheetrock. So the code allows them to build a sheetrock enclosure around the duct in lieu of wrapping the duct. It's an option. It's not used much because, once again, space is critical, but the code does allow them to do that to create a shaft. The one picture I had showed earlier showed the duct being dropped into a furnace and heated from the outside. As these ducts, either air or grease, these happen to be grease ducts, run through the building, they travel horizontally and vertically. And when they're going vertically, they are acting as a zero clearance product and as a shaft alternative. A shaft being something that goes through the floors and is maintaining the fire in the zone where its origin. So if there's a fire inside one of these grease ducts, it's running vertically, it needs to stay within the grease duct. Shafts are, if you look at this picture, this is a very large shaft. We'll say it's probably 20 feet wide, and the 2 grease ducts are traveling up through that. The grease ducts are basically shafts within a shaft is what we're doing in this picture. If the duct travels up on its own through the shaft, if you look at the picture on the left-hand side, the penetrations need to be fire stopped. So this is the shaft enclosure language in the mechanical code 506.311. Or 506.3.11. And you've got to keep the grease duct 18 inches from combustibles or 6 inches from limited and non-combustible that are not less than 6 inches away from the duct. And it also says in that section that the duct shall serve a single grease duct enclosure. A single grease duct shall not contain other pipes and other wiring. Now, this is important to the contractor designers and installers, because what often happens, and you've seen in the pictures previously, but this is a good example here, these are 4 grease ducts sitting right next to each other. And it's quite often hard to get the wraps around the individual ducts. The ones on the left, you can. The ones on the right are pretty close together. So you need 2 layers of wrap around the duct. We get asked a lot, well, can we wrap 2 ducts together? If you look at the code language right up here, single grease duct shall not contain other ducts, pipes, or wirings. So you cannot wrap 2 ducts together in the same assembly. That does come up quite a bit. If you do have that situation occur, don't wrap them together. Call the manufacturer. They may have a solution for you. There's also language in the code concerning field applied grease duct enclosures, continuously covered on all sides from point in which the duct originates to the outlet terminal. If you notice, I've got a line underlined at the very bottom, partial application, that's coming up in 2 slides. So the duct needs to be continuously covered, which means you can't just wrap in one area. If you're gonna wrap the duct, you have to wrap it continuously. This duct is wrapped. It is not compliant with the code. The inspector didn't catch it. He should have caught it, but he didn't. So if you look at this picture, it's not compliant with the language, continuously covered on all sides, point of origin to the outlet terminal. Should have been. The next section, which I mentioned earlier, partial application of field applied wraps shall not be installed for the sole purpose of reducing clearances to combustibles in isolated areas, such as this. The code says you need to keep the grease duct 18 inches away from combustibles. So the rationale for this wrap, if you didn't have this section in the code, would be, well, this grease duct, I'm only going to wrap it where I'm 18 inches away from combustibles, and everything else is free standing in the air. It's not going to be close to any combustibles. Therefore, I don't have to wrap it. That is not the case per the code. The code says you have to wrap the whole thing. If you're going to start it, you cannot just wrap at the area of conflict, which would be right up here. When you go through penetrations with the grease ducts, fire-rated walls, or floor ceiling assemblies, there has to be a fire stop as the duct goes through that assembly. You were containing the fire to its point of origin. If it's in a room and the duct's going through a fire-rated wall, that firewall needs to be fire stopped. If it's sheetrock, the walls needs to be framed, packed with bulk fiber, which is usually left over from the wrap where they end up cutting it, and then sealed on both sides with a penetration seal. All the manufacturers have some sort of penetration seal detail, but it'll consist of fiber packed for the insulation. On a floor ceiling assembly, it's some sort of mastic on the top. If it's a wall, you can have some sort of mastic on both sides of the wall. There are manufacturers of UL listings for this. So we've got these 3 products out there. We've got one, Unifrax has one, 3M has one. For grease ducts, they all require 2 layers for grease ducts. There was a point in time, which has long passed, prior to 2006 mechanical code, where a lot of jurisdictions, not all of them, were allowing a 1-layer system to be accepted on grease ducts. It acknowledged a different acceptance criteria, a different test standard. That standard really has been abandoned. 1-layer systems do not meet the current code. But I did mention earlier that the code does not specify what you put up there or how you put it up there in the duct. You just need to pass that ASTM test. In doing so, the 3 different manufacturers, they all have different ways of installing the product. Everybody's products are 1.5 inches thick, plus or minus a little bit. They're all similar in density. They all look similar. They're all this fibrous, this low biopersistent fiber, approximately 6 pounds, 1.5, like I said, encapsulated in a shiny scrim. And the scrim's there for several purposes, but it's to identify the product, to keep grease out, to make it handle a little bit easier. But when it comes together, when you're wrapping the duct, you take tape it, you cut it, you tape it, you put it on the duct. Different manufacturers, banding is different, how it comes together. The butt joints are different on whether their systems have butt joints or they don't have butt joints. With they do have overlaps, and where the overlaps actually come together. There's issues or there's differences where the wraps start and stop. Some you can start and stop anywhere. Some will have to start and stop at the corners, and some have to be, all the exterior joints have to be taped, other ones do not. The point being is when you're installing one of the three products, make sure you've got the literature and you're looking at it and you know what you're installing, and you're installing consistent with the literature. Banding needs to be on 10.5-inch centers max. That is defined pretty much when the manufacturers go and test it off of a 24-inch wide piece, where they've got the bands 1.5 inches in from the edge, whether it's an overlap or whether it's a butt joint, and one dead center in between that on a 24-inch wide piece, which ends up being 10.5 inches on center. So what we have here are two ducts next to each other, one being a grease duct, one being an air duct. And I put little red arrows pointing out on this, where this is a banding issue, where the red arrows are pointing to a taped joint. And if you're looking at it, and if you know what you're looking at, you can see that the banding is not 1.5 inches from the joints. The banding on this picture is probably, because this is 24 inches from here to here. They've got one dead center, but there is no banding holding this piece in place. So when if I get called on a job site, typically banding is one of the major concerns that somebody has brought up. With, is the banding proper? If you look at the picture at the bottom down here, this is a grease duct. Not that it matters from the outside when you're looking at it, but the banding is much closer on center than on this picture here. So now we're moving into out of grease ducts and into air ducts. Difference between the installation on grease ducts and air ducts, or air ducts are typically installed as a one-layer system. They can be installed as a two-layer system depending upon what standards they're actually looking at. But for the fire-rated ventilation ducts, they really are used where dampers are restricted from being used. Dampers cannot be used in grease ducts because the grease is going to mess them up. The dampers cannot be used in elevator shaft and egress stairwells and hallways, because they're egress and they're supposed to work during a fire life safety situation. And if there's a fire and there's a damper in these ducts and a damper closes, then you're not going to be able to pressurize the stairwells, hallways, or the elevators. And that's kind of a problem because they're supposed to be pressurized during a fire event. So the code basically says you can't put dampers in these sorts of ducts. So in the building code, move from the mechanical, which addresses most of the grease duct issues, to the building code. You've got ducts and air transfer openings. And once again, it's all about separation of the fire from its point of origin, keeping it to its point of origin. So as you come into or out of shafts, you typically would have a fire damper. So duct transitions between shafts shall require a shaft enclosure, provided that the duct penetration into each shaft is protected with dampers complying with this section. So there are your dampers. Ducts that penetrate fire-resistant assemblies without dampers. Okay, those are the kind of ducts I just mentioned before. That the ducts that really, for the basic reason is the code doesn't allow dampers in them because they need to work during a life safety event, or there's going to be something in the airstream that's going to muck up a damper and cause it not to work when it's supposed to work, such as a grease duct. So the wraps are used as an alternative to the fire-rated shafts. The code basically says if you can't put a damper in this duct, you need to enclose it in a rated assembly. It doesn't tell you what type of rated assembly. Often it's thought of as sheetrock, some sort of sheetrock enclosure, but it needs to be in a rated assembly. And the wraps are used in the alternative means part of the code, which basically says if you've got a product and it's tested and it complies with the intent and the provisions within the code, not less than the equivalent of what the code is, and it has to provide fire resistance, durability, and safety. So that's the part of the code that the wraps are used under. They're approved by the AHJ as a shaft and/or damper alternative. There's 2 tests out there, which they can be tested to. The majority of the systems out there are now tested to an ISO standard, which is technically an equivalent to an ASTM standard, which was shown earlier when I had showed the image of that duct, which was dropped into the furnace, and when it was fired from the outside. It gives us, what we get with that is we get 2-hour rating on stability, integrity, insulation, and a 2-hour fire stop with F&T ratings. Once again, containing the fire to its point of origin. The ISO standard that the 3 manufacturers have tested to, the definition of in the standard, it says that the general purpose of the test is to measure the ability of representative duct or duct assembly to resist the spread of fire from one compartment to another without the aid of dampers. Once again, containing the fire to its point of origin, this is without dampers, and this is purely for ductwork. The other test out there is a ASTM 2816. That is that's gaining some traction. It's probably going to be part of the code within a couple more cycles. The code is very slow to change and adopt actual test standards, but at this point in time, the code for grease ducts specifically says you've got to pass it to an ASTM test 2336. For the shaft alternative on the air ducts, at this point, it basically just says it needs to be you need to put it in a rated assembly. The differences between the 2 test standards which are out there is one's prescriptive and one suggestive. What does that all mean? The ISO test, the laboratories will list specific aspects of the test, what you pass, without listing it as a complete assembly. They'll list F ratings, they'll list F&T ratings. The ASTM standard, it's all or none. You have to pass every aspect of it or you do not get a listing. So these are what the ventilation duct listings look like. Varies some of to the grease duct listing, shows the install on the ventilation or the grease duct listings. You are not allowed to have any through joint penetrations. You always need one joint covered up somehow. On this system, since it's the air duct systems, since they're one layers, there's always a 3-inch overlap, whether it's our system or the competitive system. You need the overlap because if you're just butt joining it, there's nothing covering the top of it and the heat's going to get through. In the grease duct assemblies, same thing with that, is you cannot have a straight through joint. Typically, that's taken care of by the 2-layer system where the joints are staggered. If for some reason somebody's installing the 24-inch wide joints directly on top of the 24-inch wide joints underneath it, that's going to be a problem. The manufacturer's instructions clearly say you're supposed to stagger the seams. And I am pretty much on target, I believe. That's all at this point.
Well done. We don't have any, I don't see that any questions have been submitted, so I'll kind of give I'll stall for a little bit and give people some time to submit something. So with that, I do just want to say thank you again to Morgan Advanced Materials and Thermal Ceramics for your time. Thank you, David, and thank you, Chris. I do want to mention that if you can go on to distributioninternational.com and under resources, click on the DI 101 webinar series. There's a link for you can sign up to make sure you are on the list to receive the invites for this. You can also follow us on LinkedIn, where we regularly post announcements about upcoming webinars and other fantastic information that you just don't want to miss. So with that, we are recording this webinar, and so we will post this on the DI YouTube channel and have it there as we build up our library of resources. So that's also, check us out on YouTube and look at the great resources that Distribution International has there available for you. Still no questions. I did the best stall tactics I could do, David. So you obviously answered absolutely everything during your presentation.
Maybe I put them to sleep.
So I will say that if you, I will say to the DI associates that are on the webinar, if you think of any questions later regarding anything that David talked about, reach out to our sourcing department. Brandon Hollis is your go-to guy for this product category. Reach out to him, say, hey, I've got some questions from the webinar. Can you please get me in touch with David and Chris? And Brandon would be happy to do that. So please reach out to him, or if you have Chris's contact information, obviously feel free to reach out to him directly as well. With that, thank you so much, everybody. Please stay safe and treat everybody well. Thanks and have a good day.